your last lesson? You already learned it, but we're just reviewing it. Okay. So we have 3 minus 3 sine x equals 2 cos squared x. And I want it from negative 180 to 180. Inclusive. And then 2, I want you to do tan squared x minus 1 equals secant x. From negative pi to 2 pi. Round brackets. For number 1, what's the very first thing we're going to have to do? Yeah, get it equal to 0 because one of them is a squared, right? So you can either move the left to the right or the right to the left. I'm going to go least resistance, so I'm going to move this one. So I get negative 2 cos squared. You can move it the other way if you want positives. It doesn't matter. Minus sine x, 3 sine x plus 3 equals 0. And what's our problem? We have sines and coses, yeah. So we always have to switch the squared one. So we're switching just the cos squared, just this part. So the negative 2 sits out front. And we get 1 minus sine squared. Minus 3 sine x plus 3. Okay, you solve that one out. This one has a basic tan squared and a secant, so what are you going to have to do? Move it all to one side, set it equal to 0. Whenever you have a tan squared x minus 1 like this, you can just put the 1 over and solve. But when you have a tan squared with a degree 2 with a degree 1 with a comp, you have to move it over, always. So try those two out. So I'm going to get negative 2 plus 2 sine squared x minus 3 sine x plus 3. And I get 2 sine squared x. Please be quiet. Minus 3 sine x. Guys. Plus 1 equals 0. And then I have to let m equal sine x. Two m squared minus 3m plus 1. Yep. You guys, they can hear everything you're saying, just so you know. The mic's really good, so keep that in mind. So 2m squared minus 2m plus minus 1m plus 1. Take out a 2m and we're left with m minus 1. Take out a negative 1, we're left with m minus 1. So we get m minus 1 equals 0, 2m minus 1 equals 0, m equals 1, m equals a half, and m in this case is sine x. Sine x equals 1 here, which is pi over 2, which fits the domain. Why'd I use radians? 90. And then, does any of its coterminals fit? No, if I subtract from it, I'm going to get negative 270, which is too big. And then sine equaling a half is here and here, positive a half, which is at 30 and 150. If I do their coterminals, I'm going to get negative 210. By subtracting 360, which is too big, or too small, I guess, and then negative 330, which is way too small. So my answers for this one are x, because that's the variable, I have to check, equals 30, 90, 150. It doesn't matter the order. This one, the tan squared is the one that has to go. Tan squared up here, if I move the 1 over, tan squared is secant squared theta minus 1. So this can be replaced with secant squared theta minus 1, and then move my secant over. I don't have to distribute or anything with this one because it doesn't have a 2 in front or anything like the cos did. Then I get secant squared x minus secant x minus 2 equals 0. My only problem when I have not a primary trig ratio, but a secondary one, is I'm going to get non-permissible values. Because I'm going to have a cos in the denominator. So I'm going to go up to here and say cos x can't equal 0. And x equals 0 here and here. So x can't equal pi over 2 plus pi n nei. Yeah.
So even though we don't say in our answer, we still have to put the non-permissible values for this one, right?
Yeah.
So do you just put it off to the side?
Yeah.
If they give you a domain, you have to do general filtering.
No, you can give just the question, that ones that don't fit in that domain.
So
Yeah.
anywhere where there'd be undefined.
So you would just say pi over 2, negative pi over 2, and 3 pi over 2. Because those would be the three that actually fit in that domain. Then we say let m equal secant x. So I get m squared minus m minus 2 equals 0, and I can do product sum. I get m minus 2, m plus 1. And then I get m minus 2 equals 0, m plus 1 equals 0, m equals 2, m equals negative 1. And normally seeing 2 is a problem, like with sine and cos, because it maxes out at 1 and negative 1, you get no solutions. We agree? But this isn't sine or cos, this is secant. So secant x equals 2 over 1, and secant x equals negative 1. So then I can immediately go cos x equals 1/2, because secant is r over x. So cos is x over r, just flips. And then cos x negative 1 over 1, which is still just negative 1. Then I go to where cos is positive 1/2, which is at 60s, so here and here. So this is pi over 3, and this is... And both of those fit, but then I have to, bless you, check their coterminals. So I minus 2 pi, or visualize it, which would be negative pi over 3. And then minus 2 pi, this would be negative 5 pi over 3, which is too big. So this would be a solution, this would be a solution, so would this one. And then cos x equals negative 1 is here. Which is at pi. And then it's coterminal. I subtract 2 pi and I get negative pi. But what's my problem?
Or what's
It's not it's not a square bracket, it's not included, it's a round bracket. So this one actually isn't counted, and my solution would just be pi. So my answers are going to be variables x equals, and I have to check. I can't have, x can't equal plus or minus pi over 2 and 3 pi over 2. Does it equal any of those? No, so we're okay. And we can go plus or minus pi over 3, 5 pi over 3, and pi. Yeah.
In theory, if you missed like one of them on a test, would you still get marks for the others, or would it be like?
No, you'd be fine. You'll lose like 0.5, depending on how far back your oopsie is. If it's just like you missed another solution because you didn't do the whole domain, then probably 0.5. Yeah. Cos. So up here you have secant. This is 1 over cos. And you can't have a denominator of anything. So whenever you have a secondary trig ratio, anytime, or tan, so tan or secondary trig ratio, you will get non-permissible values. Because tan is sine over cos. So you still get the same thing. Okay, 3, you're going to solve this one. Cos x plus pi over 6. It's different. Minus cos x minus pi over 6 equals 1. What do you have to do when you immediately see these?
Change it out to the formula.
Yeah, go to your formula sheet. Plug it into the cos A plus B, cos A minus P1. And then 4 is 4 minus 2 sine x. People don't spot this one as obvious as the squared. Cos 2x. Remember, you can't do anything with a cos 2x. You're going to have to replace it every time. And I would replace it with the one that has a sine squared. Why? Because there's a sine. See that? Yeah.
We all thought we were just getting imaginary numbers.
So here we'd get cos x, cos pi over 6. And I always put them in brackets, just so I know they're separate. Minus sine x, sine pi over 6. Now you have to remember, we're minusing this whole thing. So we're minusing cos x, cos pi over 6, plus sine x, sine pi over 6. Equals 1. So pi over 6 for cos is what? So it's root 3 over 2 cos x minus 1/2 sine x. Then technically minus root 3 over 2 cos x minus 1/2 sine x. Equals 1. Does anything happen? The ugly things go away, right? -1/2 and -1/2 is -1/4. Sine x equals 1. And then I just multiply by?
How?
I was multiplying. Stop it. My game is gone. I told you, it blew away. Negative sine. Oh, marker. Whatever.
It's okay.
Don't bully me. It's okay. I deserve it. All right. So we're here. Which is, I'm going to use degrees because if I gave you guys general form options, most of you would pick that. I'll write the radians after. So it's going to be 270 degrees plus 360 degrees N, NEI. And then X equals 3 pi over 2 plus 2 pi N NEI if you chose radians. Then the one that I really wrote wrong. Okay. So this one we have to replace the cos 2x with these. I don't remember. Yeah, 1 minus 2 sine squared x. We have to pick the sine one because we have a sine sitting here. So I'm going to move them over so I get a positive. So I'm going to get 2 sine squared x minus 7 sine x. And then I'm going to minus the 1, which is a plus 3. And then I'm going to go. So I'm going to get 2m squared minus 7m plus 3 equals 0. The multiply is going to be 6. Now it's going to be -7. -6 and -1. 2m squared minus 1m minus 6m plus 3. Two m minus 1. So we get m equals 3, and m equals 1/2, which this is sine x equals 3. And when I see sine x equals anything above 1 or minus 1, I get really happy. Why? Because there's no solution. Yeah. Go for it.
Wait, so you
It wouldn't be does not exist. Does not exist. It would be more like no solution exists.
So do you have to fit in like, x cannot equal 1, or just no solution of this?
Sorry?
Like, do you just put no solution?
Yeah,
or do you have
'cause-
to put x?
No.
That it's not really a non-observable value.
No, it's just no solution. There's no place where this crosses. Like sine x is here, and then 3 is here, and they're just never crossing, so there's no solution. And then this one, sine x equals a half is here and here, which is at 30 and 150, or pi over 6, or 5 pi over 6. So I'm going to get x, because it's x, equals pi over 6 plus 2 pi n NEI. And x equals 5 pi over 6 plus 2 pi n NEI. Or in degrees, it would be x equals 30 degrees plus 360 n NEI. Or x equals 150 degrees. Okay. Enjoy. Verify. These are practice. What's the steps for verification? Rewrite, sub in, and go to unit circle and do. Plug in values, right? Don't go like tan of 30, and then the next step you go sine of 30 over cos of 30. You're not going to do that. You're going to do tan of 30, and then you're going to write the answer to sine of 30 divided by cos of 30 off your unit circle, right? So, first step is rewrite it. Second step is fill in the 30, the 60, whatever it is. Third step should not have any coses or tans or anything left. It should all just be numbers off your unit circle. That should be the third step. Okay. Bless you. And then I would immediately go like I'm immediately filling in values. Cos and sine's gone on the third step. So I'm going to prove it after. Okay. So we're going to go common denominator. So we're going to go root 3 minus 1 over 2. Now I can flip it because it's full fraction, full fraction. These cancel, and I get root 3 minus 1 over root 3. And then rationalize. Root 3 times root 3 is 3. Minus 1 times root 3 is minus root 3 all over 3. And I'm going to let that sit and see what happens. Bless you. Sine of 30 is a half. squared. Tan of 30 is root 3. Nope, over 3. Now I'm trying to remember. Tan of 30 is a half. Yeah, it's root 3 over 3. Wait. It can be a half divided by root 3 over 2. A half times 2 over root 3. Yes, it's root 3 over 3. I was questioning my brain power, but that's right. And then plus root 3 over 2. 60s are root 3s, 30s are root 3 over 3s. And then we're going to get 1/4 minus root 3 over 3 plus square the square root, get 3 over 4. And 1/4 plus 3 over 4 is what? 1. Minus root 3 over 3. Make this be a 3 over 3. So it's going to be 3 minus root. Happy dance. Left side equals right side. Don't forget that LS equals RS.
Does it matter if we put negative root 3 plus 3 or 3 minus root 3?
Nope.
As long as they look the same?
As long as you have the negative sign in front of the root 3. So if you
Yeah,
went negative
for
root
both
3
of them,
plus
right.
3 over 3, you're fine.
Okay.
Okay, I'm going to do the proof over here just because I have space. But I'm going to do the proof the way I think you're going to do the proof, and then I'm going to do the proof the easier way. So we have cos x minus sine x over cos x. And then remember, you're trying to prove that, so you can't start working at it on the first step. The first step is to rewrite sine squared x minus tan x plus cos squared x. So sine squared x plus cos squared is x is actually 1. I don't need to rewrite this side. What am I doing? So if I want to, so that it actually looks better, I can go sine squared x plus cos squared x minus tan x. So squishy. This becomes a 1 off your formula sheet, minus tan x. And then I assume people are going to go sine x over cos x. And then you're going to multiply this by cos x over cos x. So I get cos x minus sine x over cos x. Which actually isn't that much longer. I just see the left as I can split it. So left side equals right side. What I would do is, most people forget, they remember if you have common denominators, you can put a fraction together, but they forget that if you have a denominator with 2 numerators, you can actually split it. I'll show you what's another way this could have been done. I'm going to put that back down, don't freak out. Do it in blue. So we would still rewrite it, cos x minus sine x over cos x. And then sine squared x minus tan x plus cos squared x. Just showing you another way so that you can see something different that might pop in your head if you get stuck at a different point on a test. So this becomes 1 minus tan x. Now, a rule that everyone forgets about is they forget that you can split a denominator up over. So if I gave you cos, right here, if I gave you cos x minus sine x, cos x, you know you can go cos x minus sine x over cos x. But you forget that this actually can reverse and go back that way. So whenever you have 2 numerators over denominator, you can actually split them. So I could rewrite this each over the denominator, cos x over cos x minus sine x over cos x. And then I have 1 minus tan x, and they match. So remember that when you have 2 numerators over 1 denominator, you can split them. It's absolutely correct doing it the right way, though. Yep. Underneath. Your proof should be vertical. Please don't do like moving proofs. They'll always give you enough paper, like they'll usually do a proof on 1 page. So there's plenty of room to work your way down. Don't like arrow your proofs around and make so. Yeah. All right. Okay, proofs. You can go to a board if you want to do a proof, or you can sit down. I don't really care. Pardon?
And clearly, old people follow bias if they got told that I have broad shoulders, no hips, but I don't have hair. What a nice guy. And you're talking about it.
Shh. So we would never do this out of the question, but I'm doing this because I wrote it anyways. It was my own handwriting. But we have 1 plus cos x, all over 1 is the numerator, divided by tan is sine x over cos x, plus sine x over 1. So I'm going to have to multiply this one by cos x and cos x, which I would never squish like this. I would take up the whole page, and I would make it pretty. 1 plus cos x, I'm not even joking. Yeah. And then divided by, can't flip until I have a full fraction. Sine x plus sine x cos x. This is killing me that I'm writing over this, but don't do this. Make sure you write all on the left side. Erase your line and try again. Okay, so we get 1 plus cos x over 1. Now I have full fractions. I can flip them. Cos x over, I can take a sine x out. Remember when you're stuck, 98% of the time it's a GCF. Okay. Shh. Oh, really need to find that setting. 1 plus cos x. Now, is 1 plus cos x same as 1 plus cos x? Yes, because they have a plus sign and they're attached. That's the only reason why those can go away. Then I'm left with cos x over sine x. And then I could be a rebel and never touch the right side and go cotan x. Left side equals right side. And they match. Number 2, I gave myself more room. Left side, right side. Don't work it out of the question I am because I wrote it. So we have 1 over cos x minus cos x over 1. So I'd have to multiply this one by cos x, cos x. I'm not dealing with that side until I do this. So I get 1 minus cos squared x over cos x. And 1 minus cos squared x is sine squared x. And then, if I wanted to, I could actually, what do I have to do? I could flip it and do some math over here. Or I could say, hey, it's so easy over here now. So I'm going to go sine x over 1 divided by cos x over sine x. This is the point where you should be getting happier. So sine x over 1 times sine x over cos x. At least at this point you should be happy. And you get sine squared x over cos x. Oh my gosh. No, we're back. Yeah. Okay. Page 320, numbers 1 to 3, is solving.